An exoplanet that could be entirely covered in water has been found by a team of astronomers. The exoplanet TOI 1452b, which orbits one of two tiny stars in a binary system in the Draco constellation, approximately 100 light-years from Earth, has been found, according to an international team of researchers. The exoplanet is somewhat larger and heavier than Earth, and it orbits its star at a distance where its temperature is just right for liquid water to exist on its surface. It may be an ocean planet, a planet entirely coated in a thick layer of water, according to the scientists. This would make it comparable to a few of Jupiter's and Saturn's moons. Astronomers first learned about this exoplanet thanks to NASA's TSS satellite telescope, which scans the whole sky for nearby planetary systems. Scientists anticipated a planet that would be around 70% bigger than Earth based on the TSS signal, which revealed a modest brightness drop every 11 days. Charles Cadu is a member of a team of astronomers that conduct ground-based follow-up studies of candidates found by TSS to verify their planet type and features. He employs PESTO, a camera mounted on the telescope of the OMM. The OMM was essential in determining this signal's nature and calculating the planet's radius. This wasn't a regular inspection. We had to confirm that the TSS signal coming from TOI 1452, the larger of the two stars in that binary system, was indeed coming from an exoplanet. The host star TOI 1452, one of two stars of comparable size in the binary system, is much smaller than the Sun. The TSS telescope perceives the two stars as a single point of light because their separation is so tiny, 97 astronomical units, or about 2.5 times the distance between the Sun and Pluto, and they circle one another. However, PESTO's resolution is sufficient to identify the two objects, and the photos demonstrated that the exoplanet really orbits TOI 1452. This was verified by a Japanese team's later observations. Innovation at work. Then, the astronomers monitored the system using SPIRU, an instrument mounted on the Canada-France-Hawaii telescope in Hawaii, to calculate the planet's mass. Because it works in the infrared spectrum, where low-mass stars like TOI 1452 are brightest, SPIRU is perfect for researching them. SPIRU was mostly developed in Canada. The planet's mass, which is thought to be close to 5 times that of Earth, was only estimated after more than 50 hours of observation. Even then, they created a potent analytical technique that could find the planet in the SPIRU data. The LBL approach, also known as line-by-line, enables us to remove a large number of parasite signals from the SPIRU data and to show the faint trace of planets, like the one identified. A world of water. The radius, mass, and density of the exoplanet TOI 1452b point to a world that is significantly different from our own. Despite the fact that it is likely rocky like Earth, in essence, Earth is an extremely dry planet, although we frequently refer to it as the blue planet because the ocean covers around 70% of its area. Water really makes up a very small portion of its mass, less than 1%. Water may be present in far greater amounts on certain exoplanets. Recent discoveries and calculations of the radius and mass of several exoplanets with sizes between Earth and Neptune by astronomers, about 3.8 times larger than Earth. Some of these planets have densities that are only explicable if a significant amount of their mass is made up of elements like water that are lighter than the elements that constitute the Earth's interior. These hypothetical planets are referred to as ocean planets. One of the most promising possibilities for an ocean planet that has been discovered so far is TOI 1452b. Its mass and radius point to a far lower density than one would anticipate for a planet like Earth, which is mostly composed of metal and rock. Water may make up as much as 30% of TOI 1452b's mass, according to their research. This estimate is equivalent to that of other naturally existing satellites in our solar system, including as Jupiter's moons, Ganymede and Callisto, Saturn's Titan, and Enceladus. The James Webb Space Telescope is the ideal tool for continued study of an exoplanet like TOI 1452b. It is one of the few known temperate planets that display traits associated with an ocean world. Scientists may attempt to analyze its atmosphere and verify this theory, since it is very near to Earth. Additionally, it happens to be situated in a part of the sky that the telescope can watch all year long. To comprehend TOI 1452b, our observations with the James Webb Space Telescope will be crucial. We will schedule time on Webb as soon as we can to examine this unusual and fascinating planet. Another super-Earth-like planet has been found by astronomers, and it is just 26 light-years away. It likely has an atmosphere. The planet they found, known as Gliese 486b, is just 30% larger than Earth and has a mass 2.8 times that of our planet. We deduce that its composition is comparable to that of Venus or the Earth, which have metallic nuclei within them, by calculating its mean density from measurements of its mass and radius. The authors write, Gliese 486b travels 2.5 million kilometers in a circular orbit around its host star every 1.5 days. The star is far cooler than our Sun, so despite being so close to it, the planet has likely preserved some of its original atmosphere, making it a strong candidate for further study with the next generation of space and ground telescopes. Gliese 486b constantly faces the same side of its host star because it rotates on its axis at the same rate as it orbits the star. Gliese 486 is considerably fainter and colder than the Sun, yet because of the radiation, the planet's surface warms up to at least 700 K or 430 degrees Celsius. Because of this, Gliese 486b's surface resembles Venus' surface more than Earth's, with a scorching, arid terrain and lava rivers that are blazing. Gliese 486b, in contrast to Venus, could have a thin atmosphere, because solar irradiation tends to evaporate the atmosphere, and the planet's gravity tries to hold it back. Calculations using current models of planetary atmospheres can be accurate for both hot surface and thin atmosphere situations. These days, it is challenging to balance the two contributions. It was pure serendipity that Gliese 486b was found. Its whole surface would be covered in lava, and its atmosphere would be made of evaporated rock if it had been around 100 degrees hotter. On the other hand, Gliese 486b would not have been acceptable for the follow-up observations if it had been around 100 degrees colder. The orbital inclination of Gliese 486b, which allows it to cross our line of sight and obscure part of the star's light and produce transits, will be studied in more detail in next scheduled observations. During Gliese 486b cycles, just before it vanishes behind the star, they will also do spectroscopic measurements using emission spectroscopy, which they will do when the hemispheres of the planet are visible as phases of the planet, similar to our Moon's phases. Information regarding the conditions on the planet's sunlit, heated surface will be found in the observed spectrum. Thanks for watching. Take a look at some of our other videos that show great discoveries by the James Webb Space Telescope. Don't forget to like the video and subscribe to our channel. Until next time.